Hi, welcome to iEducator. This is Teacher Jeff. I'm an educator and an engineer by profession. And today we will discuss Chapter 1. And Chapter 1 is all about the overview of statistics. Now, the main objective of this lesson is to present an overview of statistics as a discipline because every student is expected to gain knowledge and mastery of the basic statistical concepts and terminologies, which are quite necessary in understanding more advanced topic in statistics discussed in the succeeding unit or module. Specifically, after completing this unit, the students should be able to first retrail the basics of statistics. Second, discuss its scope and functions. And third, weight the gravity of this topic offering towards one's role or function. Now, in today's lesson, it is divided into three parts. First, we have the nature of statistics, which includes scope of statistics, divisions of statistics, and population versus sample. And the second part is the types of data, which includes types of variables and scales of measurement. And the last part, we have methods of data collection. So what is meant by statistics then? Now, if we say statistics, according to American Statistical Association or ASA, statistics is the science of learning from data. Now, the word statistics can be defined in two senses. In plural sense, it is a set of numerical data or observations. Examples are vital statistics in a beauty pageant. You have annual income or yearly income, and you also have monthly household expenses, all right? So these are just some of the few examples of the first definition of statistics, which is a set of numerical data or observations. On another definition, in singular sense, it is a branch of science which deals with the collection, presentation, analysis, and interpretation of results objectively in the presence of uncertainty. Now, if we say collection of data, it refers to the different data gathering techniques such as interview, questionnaire, observation, and recording. And if we say presentation of data, it refers to the process of organizing data such as tabulation, presenting through the use of charts or graphs. Moreover, analysis of data refers to the method of obtaining necessary, relevant, and noteworthy information from the given data through the use of statistical tools. And lastly, if we say interpretation of results, it refers to the tools of drawing out conclusions, descriptions, inferences, or generalizations from the analyzed data. So what is then the scope or coverage of statistics? Well, statistics is divided into two scopes. First, we have the branch of knowledge, and second, we have data. And it is a branch of knowledge because we collect data, we represent data, or we present data, we analyze the data, and then we interpret the results. And in collecting data, there are actually different data gathering techniques that we can use, such as interviews, through conducting survey questionnaires, through observation, or through recording. And in presenting the data, what we usually do is to organize them to aid better understanding. We can organize them by means of textual, graphical, and tabular presentation. Now, there are three ways of analyzing our data. First, we have univariate. Second, we have bivariate. And third, we have multivariate. When we say univariate, this is the simplest form of analyzing data. Uni means one. So in other words, your data has only one variable. Most importantly, the very thing that we need to take note if we talk about univariate analysis is that it doesn't deal with causes or relationships, and its major purpose is only to describe. On the other hand, if we say bivariate analysis, your data is composed of two variables. And because it has two variables, it involves relationships between the two variables. And lastly, if we say multivariate analysis, it is a set of techniques used for analysis of data sets that contain more than one variable. And the techniques are especially valuable when working with correlated variables. And in interpretation of results, it can either be narrow or broad interpretation. When we say narrow interpretation, it is a brief and concise one, while broad interpretation is long and detailed. Now, the second scope of statistics is data. As you can see, there are four types of data and measurement scale. We have nominal, ordinal, interval, and ratio. If we say nominal data, these are used for labeling variables without any quantitative value. It could simply be called labels. Again, if we talk about nominal, there is one key term that we should always remember, and that is to name. So by the name itself, nominal, to name. So that's the key term that we should always remember. It's either to name or to label. Now, examples of nominal data, that would be if you are answering a survey questionnaire or a Likert scale, most likely you will be asked, what is your gender? So gender, it can either be male or female. So you are just simply naming or labeling. Aside from gender, you will be asked as well, what is your hair color? So is it brown, black, blonde, gray, or other? Okay, so if I choose brown, then you are just simply naming or labeling. So that's nominal data. If we say ordinal data, by the term itself, ordinal, so meaning if in nominal, the key term that we should always remember is to name, on ordinal data, the key word that we should always remember, that would be order. Again, it's order. If we say ordinal, it is the order of the values is what's important and significant, but the differences between each one is not really known. So for example, again, going back to a survey questionnaire or a Likert scale. So if you're answering a survey questionnaire, you will also be asked, how do you feel today? So there is an order of your feelings. So for example, number 1, very unhappy, 2, unhappy, 3, okay, 4, happy, and 5, very happy. Okay, there is an order. Okay, that's ordinal data. So how do you feel today? Based on our example, in each case, we know that number 4, example, from a point scale of 1 to 5, where 5 is the highest and 1 is the lowest. Now, based on our example earlier, in each case, we know that number 4 is better than number 3 and number 2 feeling, right? But we don't know, and we cannot quantify as well how much better it is. For example, is the difference between okay and unhappy the same as the difference between very happy and happy? We can't say so. So it is typically measures of non-numeric concepts like satisfaction, happiness, discomfort, etc. For example, how satisfied are you with our service? Using a point scale of 1 to 5, where 1 is the highest and 5 is the lowest. So 1 very satisfied, 2 somewhat satisfied, 3 neutral, 4 somewhat unsatisfied, and 5 very unsatisfied. So again, going back, if we see ordinal, the keyword that we should always remember is order. So there is a certain ordering. And next type of data or measurement scale is interval scale. In nominal, the keyword is to name. In ordinal, the keyword is order. Here in interval, the keyword that we should always remember is space in between. Again, space in between. So what is meant by interval data then? If we say interval data, these are numeric scales in which we know not only the order, but also the exact differences between the values. For example, let's say temperature. So Celsius temperature. Because the difference between each value is the same, for example, the difference between 60 degrees and 50 degrees is a measurable of 10 degrees, right? Also with the difference between 80 degrees and 70 degrees as well. So aside from temperature, another example under interval data, that would be time, because its increments are known, consistent, and measurable. Remember that interval scales are nice because the realm of statistical analysis and these data sets opens up. Example, we have central tendency. Central tendency can be measured by mode, mean, and median. Standard deviation can also be measured. All right, so this is about interval data, and the keyword to remember, space in between, because we can measure it. Next, we have ratio data. If we see ratio data, these are the ultimate nirvana when it comes to measurement scales, because they tell us about the order, they tell us the exact value between units, and they also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied. What do we mean by absolute zero? One example that we provided in interval data was temperature, right? And temperature doesn't have an absolute value because there is even a temperature that is below zero. Let's say negative 10 degrees temperature, right? So aside from temperature, we also have time. And take note that time doesn't have any absolute zero as well. It doesn't start from 0, 1, and so on and so forth, right? So in ratio data, it has an absolute zero. So for example, or the height of a building, okay, it starts with 0, meaning to say there is an absolute zero. Okay, moving on to divisions of statistics. So what are the two divisions of statistics? The two divisions of statistics, we have descriptive statistics and we also have inferential statistics. What do we mean by descriptive statistics? If we say descriptive statistics, it pertains to the methods dealing with the collection, organization, and analysis of a set of data without making conclusions, predictions, or inferences about a larger set. Now, normally, the descriptive tools that we will be employing under descriptive statistics, that would be percentage and frequency distribution. We also have ratios and rankings, measures of central tendency, statistics of association, and tables and graphs. On the other hand, if we say inferential statistics, it pertains to the methods of dealing with making inferences, estimations, or predictions about a larger set of data using the information gathered from a subset of this larger set. Meaning to say, in descriptive statistics, the researcher is only describing, okay, describing the situation or the scenario. On the other hand, in inferential statistics, the researchers are actually trying to make predictions or inferences or predictions feature or predictions about the future. Now, in order for us to better understand the differences between descriptive and inferential statistics, let's have examples. Okay, in descriptive statistics, our first example would be a college dean wants to determine the average semestral enrollment in the past 5 school years. So the verb that we may use is determine, meaning to say our college dean is just trying to describe, okay? Just trying to describe, just trying to know the average semestral enrollment in the past 5 years. In contrary, in inferential statistics, a college dean wants to forecast the average semestral enrollment based on the enrollment for the last 5 years. So meaning to say, the college dean wants to forecast what will be the average enrollment, making use of the historical data, okay, the 5 school years for the past 5 school years. Another example under descriptive statistics, a businessman wants to know his profit for the past 3 months, okay? So the verb that was used is know, meaning to say the businessman is just trying to know, just want to describe his profit for the past 3 months. And in contrary, in inferential statistics, a businessman would like to estimate his profit for the next 5 months. Okay, so that makes it inferential because the businessman is trying to do estimation of his business profit. And the last example under descriptive statistics, a chief nurse wants to determine the average number of COVID-19 patients during the last 6 months, okay? So still, this is an example of descriptive statistics because we are using the verb determine. We are just trying to know, we are just trying to describe, and we are not trying to make inferences. So in contrary, in inferential statistics, a chief nurse wants to predict the number of COVID-19 patients for the next 2 years. And because it's predicting something in the future, so that makes it an example of inferential statistics. All right, so moving on to population versus sample. So what is the difference between the two? If we say population, it refers to the collection of all cases in which the researcher is interested. In its general sense, this pertains to the totality of objects, animals, persons, materials, happenings, or events under investigation. On the other hand, if we say sample, it refers to a portion or a subset of the population from which the information is gathered. So theoretically, a sample must be a representative of the population from which it is taken. Now, in order for us to better understand the differences, let us have some examples. Okay, first example of population. all students of ABC University. Okay, so all, you're making use of the word all. Okay, that's population. So how do we make this example as a sample example? So to make this as a sample example, engineering students of ABC University, okay? Because engineering students of ABC University are just representative samples of the totality of all students of ABC University. Okay, another example would be all patients of surgical ward in a hospital. And on the sample example, patients of surgical ward in hospital with respiratory complications. So out of all the patients in the surgical ward, you actually categorize the illness of the patient. So in order to make it a sample example, so patients of surgical ward in a hospital with respiratory complications or with COVID-19 complications, okay? And the last example, all companies manufacturing candies. And under sample, companies manufacturing candies that have employees less than 300, okay? So I hope this is clear. This is just very easy because a population, the totality of objects, population, etc. While a sample is just a representative of the population from where it is taken. The next key area that I'm going to be discussing right now, that would be the types of data. And under types of data, we have two special definitions. First, variable, and second, we have data. What's the difference between the two? If we say variable, it is a characteristic, description, or attribute of persons or objects which assumes different values or labels. And if we say data, it is a collection of variables. Now, in order for us to better understand the difference between the two, let us have some specific examples. So let us discuss first examples under variable. So under variable, going back to our definition, it is a characteristic, description, or attribute of persons or objects which assumes different values or labels. For example, we have height, age, and weight. So height is 5 feet, 4 inches. For the weight, you have 120 kilograms. And for the age, you have 20 years old. So in a classroom setting, and there are, let's say, 20 students, of course, the height, age, and weight will vary because not all students have a height of 5 feet, 4 inches, right? There are some who are 6-footer, and there are some who are below 5, okay? And the weight as well and the age. Another example would be gender, religion, affiliation, and civil status. For gender, it's either male or female. Religious affiliation, you have Roman Catholic, either Adventist, Protestant, Mormons, etc. And for civil status, you have single, married, separated, or widowed. Okay, so these are examples under variables. So what are the classifications, the two classifications of variables? Under variables, we have two classifications. We have qualitative variables, and we also have quantitative variables. If we say qualitative variable, this yields categorical responses. Examples, civil status, okay? Religious affiliation. So meaning to say in qualitative variable, you need to always remember that we are only talking about the attributes, the characteristics of a certain person, object, and so on. We are not talking about numbers. This is not numeric in nature, okay? So that is qualitative. What about quantitative variable? If we say quantitative variable, This yields numerical responses representing an amount or quantity, meaning to say this is the complete opposite of qualitative because quantitative is numeric in nature. For example, number of children in the family, blood pressure, and a lot more. And there are two types of quantitative variables. First, we have discrete quantitative variables, and second, we have continuous quantitative variables. So what's the difference between the two? Okay, when we say discrete quantitative variable, it assumes finite or countably infinite values such as 0, 1, 2, 3, and so on, and are usually obtained through the process of counting. For example, number of students, number of patients. So the very thing that we should always remember if we talk about discrete, first, it is countable, and second, it should always be whole number. Okay, so this should be countable and whole number. On the other hand, if we say continuous quantitative variable, it assumes values which are associated with points on an interval of the number line. Meaning to say, if your discrete is a whole number, your continuous is not, because there are points or fractional in nature. For example, height, okay? Others have 5 feet 1 inch, 5 feet 4 inches, okay? For the weight, you have, let's say, 50.55 kilograms, right? Or 70.8 kilograms. For the temperature as well, okay? So there are points on an interval of the number line, okay? And as mentioned earlier, we have 4 types of scales of measurement or data. Variables can also be classified according to the levels of measurement. First, we have nominal data. Second, we have ordinal. Third, we have interval. And fourth, we have ratio data. Okay, just a brief recap on this, since we already discussed this one in the earliest part of our discussion or lesson. If we say nominal data, it uses numbers or symbols for the purpose of categorizing subjects into groups or categories which are mutually exclusive. And again, the keywords that we should always remember if we talk about nominal data, that would be first, to name, and second, to label. Okay, examples are gender and college year level. On the other hand, we have ordinal data. Ordinal data possess all the properties of nominal data, and therefore, it is an improvement of the nominal data because in here, the data are ranked or ordered in somewhat bottom to up or high to low schemes. Again, in ordinal data, the keyword that we should always remember is to order. So it's either bottom to up or high to low. Examples, students' class standing. So there is an order from a point scale of 1 to 5, where 5 is the highest and 1 is the lowest. So in this case, 5 is excellent, 4 is very good, 3 is good, 2 is fair, and 1 is poor. So we are just simply ordering our data. And for the next scale of measurement, we have interval data. It possesses all the properties of nominal and ordinal data. And so for that matter, the data are numeric in nature, and the distances between two numbers are known. And again, as discussed earlier, I would like to reiterate, your interval data doesn't have an absolute zero. No absolute zero. Examples, IQ scores of 4 students. You have 70, 140, 75, 145, okay? And next, we have ratio data. And remember that ratio data possess all the properties of nominal, ordinal, and interval data. It is also numeric in nature and has an absolute zero. Examples, your age, your monthly income, your exam scores, etc. Okay, so these are the levels of measurements or data or scales of measurements. And remember that there are also other classifications of data. Data are classified into raw data and grouped data as well. So what is the difference between the two? If we say raw data, these are those which are in their original form and structure. If we say they are in original form or structure, they are actually not arranged yet. They are not arranged into some sort of an array, okay? These are raw data which are in original form or structure. Examples, responses out from surveys. So these are raw data. Taped interviews, recorded observations, and a lot more. On the other hand, if we say group data are those placed and summarized in tabular form. Okay, you are already grouping this and summarize this into some sort of a tabulation. Okay, these are the difference between the other classifications of data. We have the raw data and the group data. And next, the next key area that I'm going to be highlighting right now, that would be methods of data collection. So what are the methods, the different methods in collecting data? So some of the methods that we will be employing in data collection, that would be observation methods, experimental methods, registration methods, archival methods, survey method, direct or personal interview method, and we also have indirect or questionnaire method. So what's the difference between all of these different methods of data collection? If we say observation method, it is the most simple data collection technique. Here, the data are obtained by merely observing the behavior of persons or objects, but only at a particular time of occurrence. The data obtained is called an observational data. And when we say experimental method, this is especially useful when one wants to collect data for cause and effect studies under controlled conditions. In this method, there is actual human interference with the conditions or situations that can affect the variable under study. And the data obtained in this method is called experimental data. If we say registration method, the respondents provide the necessary information in compliance with existing laws. For instance, data can be derived from car registration, birth registration, voters registration, and marriage registration. The use of existing studies also provide an archival method of data collection. And in this method, the primary source is the source in which the data are measured or gathered by the researcher or agency that published it. Secondary source, or the other hand, is the source from which any republication of data is made by another agency. In the survey method, the desired information is obtained through asking questions, and therefore the survey method can either be direct or personal interview method and indirect or questionnaire method. In the direct or personal interview method, there is a person-to-person contact between the interviewer and the interviewee. This is considered as one of the most effective methods of data collection because accurate or precise information can be directly obtained and verified from the respondents. And moreover, this has a higher response rate, but can only be administered to the respondents one at a time. On the other hand, indirect or questionnaire method is considered the easiest method of data collection through the use of questionnaire or a data gathering tool. Unlike the direct method, this method has a lower response note but can be administered to a large number of respondents simultaneously. Okay, so these are the methods of data collection. We have observation method, experimental method, registration method, archival method, and survey method. And our survey method has two types. We have direct or personal interview, and we also have indirect or questionnaire method. And finally, our last key area that I'm going to be discussing today, that would be sampling techniques. Now, generally speaking, data collection can be classified into two. Namely, we have census and survey sampling. If we say census or complete enumeration, it is a method of gathering data from every unit in the population. However, this is not always feasible because at times the population is unknown, and therefore the population frame is not always available. Besides, conducting a census entails a large amount of money, time, as well as effort. On the other hand, survey sampling is a method of gathering data from every selected sample in a given population. And in most cases, many researchers utilize survey sampling because it reduces cost. It has greater scope, speed, and accuracy as well. Now, survey sampling can either be probability sampling and non-probability sampling. If we say probability sampling, it is a sampling procedure in which every element in the population has a known non-zero chance of being included in the sample selection. On the other hand, non-probability sampling does not utilize random sampling, and so for that matter, it is generally short of knowing ways as to how representative a sample is. Now, let us provide some examples under probability sampling. So the following are some common probability sampling designs. First, we have simple random sampling. In simple random sampling, this is a sampling procedure in which every element in the population has an equal chance of being included in the sample. And in here, we select n units out of the n units in the population, the selection of which is through lottery, raffle, or the use of random numbers. Why are lottery and raffle draws are examples of simple random sampling? It is because in lottery and raffle draws, everyone has an equal chance to be selected, all right? Every number, every person has an equal chance, has a non-zero chance to be selected. So that is the idea about simple random sampling. Another probability sampling design that we have is called stratified random sampling. And if we say stratified random sampling, the population of n units is divided into subpopulation called strata, which consists of more or less homogeneous units. Then from each stratum, a simple random sample procedure is then performed. So in stratified random sampling, what you need to do first is you divide the total population or the whole population into subpopulation, and you call that as strata. And after having divided your population into subpopulation, you will then apply the simple random sampling technique. So let's have a specific example in order for us to better understand stratified random sampling. So example, in a study to determine the student's preference over socialized tuition fee at ABC University, a researcher may employ stratified random sampling by stratifying all students of ABC University, which refers to your population, by college, which refers to your strata or stratification variable. Again, if you try to understand our problem, it is stated that the whole population of ABC University. And remember, in stratified random sampling, first thing that you need to do is to divide the whole population into subpopulation or strata. So what we did is we divided it by college. So we have commerce, engineering, education, arts and sciences, nursing, pharmacy, and dentistry. And now, since we have already identified our stratification variable, which is by college, then we have 5 strata, and the population is stratified as follows. So these are our 5 strata. So we divided it into subpopulation. So we have first year, second year students, third year students, fourth year students, and fifth year students. Okay, so this is stratified random sampling technique. Another type of probability sampling technique, we have systematic sampling. If we say systematic sampling, this is a sampling procedure which selects the sample by taking the kth from an ordered population. In here, K is called your sampling interval, and it is defined as K equals capital letter N all over small letter n, where your capital letter N refers to your population size and your small letter n refers to your sample size. And in order for us to better understand this, let us have an example. So suppose we select 13 students from a population of 40. To employ systematic sampling, the first thing that we need to do is to determine our K, which is our sampling interval. And remember that the formula of your sampling interval is equal to the quotient of your population and your sample size. In this case, your population is 40 students divided by 13 students because we need to select 13 out of 40. So that makes it 3.08. Now, how come we only have a final answer of 3? Because remember, there is no half student, there is no 1/4 student, okay? So meaning to say we should make use of 3, whole number, okay? So hence, from an ordered population, so as you can see on the sample, you have there 40 students, which are ordered 1 to 10, 11 to 20, 21 to 30, 31 to 40. So we have 40 students as our population. And remember, we only need to select 13 students out of 40. And also based on our calculation, our K or sampling interval is 3. So what's the first thing that we need to do in doing the selection? Okay, here, let's assume that we select the student number 8 first, okay? Because the selection, remember, it is just a random selection and the researcher has the right to select which student he or she is going to select randomly. So in this case, let's just try to select number 8 student. Okay, we have number 8. And since we have encircled number 8, meaning we have selected student number 8. So that's our first selection. So we now have remaining of 12 because we are only tasked to select 13 students out of 40 rather. Now, since our sampling interval is 3, that means to say that we need to count 3 from student number 8. So if we try to count 3, so 1, 2, 3. So we will stop at student number 11. And so for that matter, we will select student number 11. And again, we will count 3, 1, 2, 3. So for that matter, we will select student number 14. And then student 17, student 20, student 23, student 26, student 29, student 32, 35, 38, student 1, and student number 4. So if you will try to count, if this is 13 all in all, so we have 1, 4, 8, 11, 14, 17, 20, 23, 26, 29, 32, 35, and 38. And yes, we have finally selected 13 students out of 40 population. All right, so this is what we call as systematic sampling. And another probability sampling design is what we call cluster sampling. This is also known as area sampling. When we say cluster sampling, this is a variation of stratified random sampling in which the strata corresponds to clusters. The units of these clusters, however, possess heterogeneous characteristics or attributes. If we say heterogeneous, meaning to say it is composed of different characteristics or attributes, not the same, okay? They are different. So for example, barangays, cities, municipalities, and provinces, because in a certain barangay, in a certain city or municipality or a province, all of the people there, living there, have different characteristics, have different attributes. So for that matter, we call that heterogeneous characteristics. And aside from cluster sampling, we also have what we call multi-stage sampling. And this is a sampling procedure wherein the population is divided into a sequence of sampling units corresponding to the different sampling stages. And another issue pertaining to sampling is the question as to how large a sample must be. Generally, there is no hard and fast rule in determining the sample size to be taken from a population of size capital letter N, or which is your population. However, most researchers often use the Sloven's formula, which is determined by N equals capital letter N all over 1 plus NE raised to the power of 2, where small letter n refers to the desired sample size. Your capital letter N refers to the population size, and your small letter E refers to the margin of error, which is usually set at 0.05 or 5%. Now, in order for us to better understand Sloven's formula, let us have some specific example. Okay, for example, how many samples must be taken from population consisting of 1,000 respondents? If you are a researcher of a certain research or thesis that you are making, of course, it is very apparent that it is not feasible to conduct a survey questionnaire to all 1,000 respondents. And so for that matter, we will be using Sloven's formula so that we will be able to determine how many out of 1,000 respondents we will be conducting survey questionnaires to. Now, for example, remember that our only given information is your population, right? You have 1,000 respondents. And so we will be using our formula to calculate the total number of our respondents. Okay, our formula is N equals capital letter N all over 1 plus NE raised to the power of 2. Now, all you need to do is to plug in the values to your formula. So in that case, your capital letter N or your population is 1,000 all over 1 plus 1,000 times 0.05, which refers to your margin error raised to the power of 2. And continuing, your total number of population is 285.71 respondents. Why should we not select 285? Because again, we are looking into the actual number of people, the actual number of respondents that we will be conducting research questionnaires to. So we will be rounding that up to the next whole number. So that means to say that the total respondents that we will be conducting research questionnaires to, that would be a total of 286 respondents. All right, so that ends our discussion for today about the overview of statistics. So if you have questions, please let me know in the comment section. And if you like this video, please don't forget to subscribe and hit the bell button for the latest update. Thank you.